Hello and welcome to the high-tech track of the DELMIA Operations World Tour virtual event. I'll be your host for this session. My name is Adrian Wood. I'm a Strategy and Marketing Director with DELMIA. We have a pretty packed agenda for you today. We're going to squeeze in as much information as we possibly can. We're going to talk about some industry vision and trends in the high-tech industry. We're going to look at some innovation in manufacturing solutions and delivery of those solutions as part of our innovation track. Then we're going to have a customer showcase. We're very lucky to have Panasonic speaking today. Mr. Alex Shimada is the Group General Manager for the Process Automation Business Division, Manufacturing Process Solution Department of Panasonic Corporation. And then we will look at some high-tech solutions specific to process engineering in the virtual world, and then we'll wrap up with some Q&A. Since we have just a limited amount of time today, I just wanted to show you sort of what we're talking about in terms of solutions in the context of the broad scope of all the operational solutions that DELMIA has for the high-tech industry. In terms of our different layers of solutions here, we have our collaboration layer, where we bring the virtual and real worlds together and allow stakeholders to collaborate effectively across all aspects of operational processes. We have our model layer, where we look at the virtual world of process engineering, fabrication, ergonomics, and so on. Our optimization layer, where we bring optimization engines to bear to solve tough industry challenges and puzzles around such things as S&OP, detailed scheduling, logistics planning. And then we have our execution layer, the perform layer, where, as we say in DELMIA, we make it happen. And this relates to production, manufacturing, lean operations, and so on. And all of this is connected to the real world. As we say at the top, virtual plus real is the overall scope of solutions. And we bring those together through integration layers to the real world, through IIoT, to connect the virtual world with the execution world, with the physical world of infrastructure and assets. So even though we've got a lot to talk about today, we're really just covering a couple of these areas. We're going to look at the model process engineering solution at the end of our presentations. We're also going to spend some time looking at the perform layer, it's the execution layer of production planning, manufacturing operations management across a variety of different areas. So we won't get at all to talk about the optimization layer today. You may have seen it in some other industry tracks if you've signed up for that. And we have other content. The collaboration layer and certainly the lean operations collaboration, hopefully you saw that as part of the executive opening, where we spoke about DELMIA 3D Lean, which is a specific lean management tool for collaborative operations. So lots to get through. We'll only cover some parts of it, but there are plenty of other resources available for you to look at other aspects of DELMIA solutions at other times. So with that, we'll get underway. We'll kick off our high-tech track here, looking first of all at the industry visions and trends for high-tech. Today, we're briefly going to talk about some of the industry challenges that are specific to high-tech. And then we're also going to talk about how the current coronavirus pandemic has added to those challenges and how we think about the next normal when it comes to recovering from those. We'll look at some mega trends in high-tech, and I think these relate to three distinct areas around humanity, connectivity, and sustainability. We'll cover each of those in detail. And we'll talk a little bit about what you should be thinking about or what you should be doing in terms of the future vision of how to align organizations in this industry towards what the future will look like. So if we look at some of the specific industry challenges of the high-tech, one of the challenges is electronics and software is pervasive across all industry segments, and it's at the heart of the digital experience transformation for all companies. Specifically, as consumers, we drive a lot of those challenges in our desire for unique and customized products. We want products that are designed for specifically what we want to do, not sold in batches. We want customization, we want configuration to be done at the manufacturing assembly level. So we drive a lot of that, and that drives a lot of explosion in terms of product variants, and that's significantly challenging for manufacturers to deal with. Regulation also plays a big part as electronics find their way into more connected industries in the automotive industry for autonomous driving, in aerospace and defense, that there's a significant amount of overhead required in terms of regulation and certification pressure that challenges this industry. The innovation itself is accelerating as we find new use cases for how we can use electronics, how they can add value to our lives and our companies and our ecosystems that we deal with. And of course, we want seamless experiences. We want all this to be integrated. We don't want to have separate components that don't work together. We want an integrated experience. Just look at how far mobile devices have come from being a simple phone. And remember when we used to carry a phone and an iPod and other devices. Now it's all together. And so the integration of these devices is a key part of driving some of the challenges. And then, of course, there's the overall supply and demand volatility. And this is something that's specifically exaggerated today with the coronavirus. We'll talk about that in a second. But this has always been a challenge in terms of some of the components, the scarcity of some of the raw materials and elements that are required to drive some of the manufacturing in terms of the products we're producing. And it has always been a significant impact in terms of how to drive effective operations, efficient operations, without adding too much cost to the overall manufacturing and supply chain. So it's obviously worth taking a second to talk about how the current coronavirus pandemic has played a role in terms of piling on to all of these challenges, and some specifics about what companies are thinking about. Thanks to industry partners and analysts that have done a lot of work in this area. We have a nice summary here of some of the key things that companies have prioritized in terms of what they're thinking about when it comes to, as we're calling, the next normal. When we look at what should companies be doing now and what should they look like post-pandemic. And there are 5 key areas that have been identified as sort of the touch points or talking points that are most important to companies. The first is around reskilling and prioritizing the safety of the workforce. And so it's clear, based upon the coronavirus, the workforce is at risk. And that's why we've had social distancing and we've had outbreaks of coronavirus in certain industries specifically, where there's a lot of labor intensive operations. And one of the challenges around that, apart from just the cost of human health, is that those people who are impacted, who have to work remotely suddenly or shelter at home, some of those people have key skills. And that risk is a dependency that poses a risk to organizations where those key skills impact operations. And so that's one key aspect of that, is the workforce. Secondly, workforce automation may be a way to help with that. I think when we talk about workforce automation, we're not talking about replacing people with machines necessarily, although that is potentially part of it. Robotics and cobotics are a key innovation area for manufacturing, but it's not just about replacing people. It's about giving people tools and automation that allows them to multitask. So I think it's about reducing the risk on those key skill dependencies and providing a way that provides a little bit more coverage for organizations that can now provide tools to workers to provide more automation and capabilities to multitask across skills. Thirdly, since supply chains are global always, this is obviously where there's been a massive impact. And the resiliency of supply chains is really all about the ability to now look at the dependencies in supply chains, about how to explore options now for bringing offshore contract manufacturing in certain countries, maybe having more second choices or a plan B for those sorts of supply chain decisions. And it's also about providing tools that allow companies to optimize across these new options for what the supply chain should look like. So there's a lot that goes into that supply chain resiliency, but in essence, it's sort of twofold. The first is, what does the supply chain look like? Can we organize it and make it so that it's a bit more resilient in terms of providing options in the future? And then if we have these options, can we optimize and plan effectively across that? That's important to maintain, business continuity. And business continuity is about connecting people and operations so that business can still operate efficiently. And there's a key emphasis on that last point about being efficient. Obviously, we can, pad the supply chain with excess inventory and materials if we want to be sure, but that doesn't drive a sustainable, business. That just adds cost, which is the one thing that high-tech industry companies cannot afford to add. It's a very lean industry as it is, and so business continuity operations have to be maintained, but they have to be maintained in an efficient manner. And that finally filters all the way down to manufacturing. And agility is a key aspect across all these different areas that companies need to adopt. We need to be more responsive as companies to adapt to changes as they happen, because clearly disruption is something that's here to stay, and it's something we should plan for the future. And all of these different areas really tie back to these three trend areas that I spoke about in the beginning around humanity, the workforce, how we automate the workforce, how we maintain operations by connecting people. Connectivity is the second part. How do we bring people together? How do we connect the supply chain and partners? How do we connect business operations and teams internally? And then finally, sustainability. We have to operate in a way that drives sustainability because our profit margins are going down as demand and supply variability goes up. And so we need to be agile in the way we respond to that so that we can drive our businesses in a cost-effective, sustainable manner. So in terms of the mega trends, humanity is the first one that I'd like to touch on. And there are a number of different areas where I think electronics and the high-tech industry play into trends related to the human experience. And the first is around the fact that products now need to be designed with the end user, the human experience in mind. We demand our lives to be connected and seamless in the way we work. And so the devices and the tools and the products that we use need to be in support of that to provide these connected experiences. But also in terms of operations and in the way we run our organizations, people drive our ability to invent, design, and deliver the results. So we need to make their work experiences seamless in the same way as well. Secondly, electronics is now a key part of safety in many different industries. There's a lot of multi-industry synergy around the high-tech trends. And this obviously impacts human lives. So in life sciences, the way we make medical devices that treat our humanity in transportation and mobility, the way we provide electronics to provide safety to the way we drive and the way we fly in aerospace and defense, in construction, the way we design buildings and the devices and applications that we build in as part of our infrastructure. And then also security and so on. So there's a very wide aspect of the way electronics are driving safety for the human endeavor across lots and lots of different industries. We spoke previously a little bit about business continuity, and when businesses fail, that now impacts millions of workers, and we've seen the impact of the recent pandemic on the workforce. We have millions of people now unemployed, out of work, because those organizations were not able to adjust and adapt to the disruption that took place. And I think the high-tech industry has fared better than others. In many ways, workers were already set up to work in more remote sort of environments or disconnected environments. And if you compare high-tech to other industries like aerospace and defense, where we're now seeing, even despite government support, now massive layoffs in terms of workers and the infrastructure of people that are involved. So we must adapt our supply chains to mitigate, otherwise the business continuity impacts us in very human ways by significantly impacting our lives and our income. Part of the ability to support the workforce is something that I think the high-tech industry, if there is any sort of brighter spot related to the challenges of the disruption we've had recently, is the high-tech industry has been able to enable the remote workforce. And so if we look at my family here going through virtual learning for my son's schooling, education, that's all supported by recent adaptations of existing tools and applications that are now being put into play so that kids can learn virtually. And the same thing has happened in the workforce. Now we are asking our workforce to be far more virtual and connected remotely, as travel has initially shut down and now is growing back slowly. But still, I think there is going to be a lot of focus and emphasis on how we engage teams and people, and how we train people and how we work with them in a far more remote environment moving forward. And finally, if we look at innovation, I know that people, specifically the CEO of NVIDIA Corporation in 2019, claimed that Moore's law is dead, that computers and processing power is no longer increasing exponentially. But even despite that, it may have slowed a little, but we're still seeing major advances in quantum computing, processing power, the ability to have mass storage at ridiculously low prices, miniaturization. All of these innovations are driving the ideas and the inventiveness of humans across different industries. And so high tech is really at the heart of the human invention process across every spectrum of what we do. So as we sit here in 2020, there is obviously a link between the human aspect of some of the trends in high tech and the connectivity. And here's one important part that I'd just like to share with you very briefly. So as we look forward to this next decade, what will 2030 be like as we link the trends of humanity and our desire to be endlessly connected to the world and devices around us? And so the population projection for the end of 2030 could be as much as 8.5 billion people on the planet. And if you look at some of the things that IHS has projected in terms of some key elements of that, potentially 6 billion mobile phones in existence, 7.5 billion people of the 8.5 billion online, and 125 billion connected objects. So the future is going to be driven dramatically in this continued direction of humanity and connectivity. And high tech is going to be at the center of enabling this future. And so the opportunity is there for companies to reap the benefit if they're ready, because it's not an easy road to get there. There's a lot of competition, profit margins are slim, and the ability to incorporate some of this agility and sustainability and have an effective workforce is going to be key to enabling the future effectively, or falling by the wayside, as so many organizations have done in high tech in the past. So why is connectivity so important as one of these mega trends that drives the high tech industry? Well, you only have to look at how it plays a role in everything from the macro to the micro scale and everything in between. So at the largest scale, if we look at smart cities and infrastructure and smart motorways, where multiple data streams are optimizing the efficiency and the sustainability in real time as our populations grow, as our cities grow, as our infrastructure grows. Also the facilities that we use for manufacturing that use systems that optimize operations through industrial Internet of Things connectivity, and also the environmental systems that fuel those facilities and keep them environmentally eco-friendly. And then everything in between. In our home, we have beds now that tell us how well we sleep and provide data back to our phones. We have vehicles that tell us where they are and when they need charging if they're electric vehicles. And we have medical devices that monitor our health and notify our healthcare providers when we need attention and so on. And so every aspect of our life and the devices we use is now connected in some way, connected to each other, connected to ourselves, connected to other systems, and they all interact together. And so the electronic and software systems are the key enablers of all of this connectivity. And by the way, while we're talking about connectivity, we'd be remiss if we didn't have at least a single slide on 5G. Remember, data is only useful when it's delivered rapidly. Otherwise, it's just history. We can go back and look at it, but we can't make decisions based upon that. Real-time connectivity turns data into information that can be leveraged, and we can make decisions from it. That's what truly makes data useful, is the ability to get it as soon as it happens and to be able to make decisions. And so 5G is going to obviously be a major enabler of this. All of these different attributes of 5G, the latency, the speed, the connection density, the number of connected devices that are possible, all of these attributes combine to drive a potential 30 to 100 times increase in overall connectivity ability. So high tech really needs to be thinking about how to capitalize this as part of the devices and the experiences that are being produced. And our final mega trend that I want to talk about is sustainability. And sustainability really has two different meanings, but they're both connected. When we think about sustainability, we think about a sustainable product, but we also need to think about sustainable business operations. And again, we've spoken about business operations previously, minimizing waste, driving efficiency of delivery, operations, logistics, making sure that we're being sustainable in the way we work, not just in the products that we make. But remember, there is also a focus on the products themselves. And it all starts with intelligent design. That's one area that, for example, DELMIA Digital Manufacturing has helped in terms of reducing prototypes and improving quality, so there's less waste and less rework needed. But the products themselves also need to be sustainable. We've got some examples here. For example, Apple using recycled materials in some of its products, Sony doing the same, but also having an emphasis on better packaging, so there's less waste after people consume products. Electrolux improving product performance, and then Fairphone, an entry into the smartphone manufacturing, making products that are more upgradable, and so today's mobile device doesn't become tomorrow's throwaway device. And again, given the explosion of product variants that we are demanding as consumers, high-tech really has to lead the way in this area, because there are so many new products coming out that we have to think about how we can make them last longer and how we can make them more efficiently and more effectively in the ecosystem. So let's take a step back. Let's zoom out to the highest level and just look at some of the big picture themes again in terms of the challenges of what's happening in terms of the trends that we need to account for in our future vision. There's two here really that stand out, I think. The first is that this acceleration of innovation that's going to continue to accelerate over time. The pace of progress will continue to be rapid. Consumers want more and more, and they want it uniquely, they want it customized, they want everything their way. And so this is going to be a continual trend of high tech in terms of what we want as consumers, and our progress is going to continue to expand. And the second thing is, I think it's clear to understand that the current disruption that we have today is going to last, for a while longer, and it's taught many companies a real hard lesson. Some companies actually, won't survive that lesson. But those that do will need a way to reinvent the way of business and prepare for future disruption, because it's unlikely that this sort of global connected nature of all of our value networks and supply chains isn't going to be impacted again in some way or in somehow in the future. So the two biggest takeaways in terms of what companies need to be thinking about in terms of addressing those future vision aspects of accelerated innovation and expecting the unexpected, to me comes down to agility and sustainability. Agility from supply chain all the way down to manufacturing daily scheduling. If change is expected, then the ability to respond to that change has to follow. Strategically, when you're planning your global supply and demand, as suppliers come and go, and as geopolitical borders rise and fall, all the way down to daily changes in shop floor activities when materials run out, or orders get changed, or the workforce gets impacted. The ability to have an agility and a level of responsiveness across every spectrum of business operations is really going to be key for companies to prepare for the future. And then secondly, sustainability. Not only from providing an eco-friendly product, which is again what consumers are looking for, but sustainable operations. And sustainable operations means a next level of efficiency. The strongest companies are not the companies that have the largest inventories or the most facilities. The strongest companies today are those companies that are the leanest. They have the ability to pivot quickly and meet whatever the market throws at them in real time on a daily basis, even through massive disruption and changes in supply and demand. So thank you for listening to this brief overview of the industry trends for high tech. We hope you will join our other presentations to hear more details about innovation in the high tech industry and some of the ways that companies are deploying these capabilities of agility, sustainability, and efficient operations in aspects of their business, so you can see some real examples of how companies are leading the way in the high tech industry. So now that we have spoken about some of the vision and trends in high tech, let's move on and talk about some of the innovations in solutions that we've seen in the industry. I'd like to talk about innovation in two different aspects. First, from a solution perspective, in terms of capabilities we can provide to companies in the high tech industry, specifically around electronics manufacturing. I'd also like to touch briefly on innovations in delivery and how we are able to still give companies the ability to transform in terms of capability and solutions despite the coronavirus cases. So we're going to cover solutions first. We're going to talk about some challenges for electronics manufacturing and manufacturing operations management, specifically around SMT manufacturing. We're going to talk about a partnership that we have with Kojiscan, which helps us provide some fantastic capabilities in that area. And then we're going to look at that manufacturing solution specific to SMT lines. So as we said in previous presentations, electronics is at the heart of the high-tech industry. They're the basic core components and capabilities that drive the innovation across the industry. So what are some of the unique challenges around electronics manufacturing, particularly in the SMT area? So obviously there's a growing demand and a growing landscape of competitive organizations in this area. It's leading to a rise of electronics contract manufacturers. So a lot of competition between organizations in this area. SMT industry challenges specifically, unique to this, are typical of what we see: production changeover issues, machine downtime, and process optimization, some of the biggest challenges that those companies face. There's a rapid pace of transformation and changes to manufacturing, components, miniaturization, the huge explosion of variants, as we've said before. There's also a rapid pace of transformation to keep those companies competitive. So the equipment, the software installation, all have to be done extremely rapidly for companies to stay ahead of the curve. And then finally, this is the one that I think is most pertinent to our presentation today. It's really about the stringent focus on quality and security standards. And quality is key, especially for high-tech manufacturing, surface mount technology lines, dealing with moisture-sensitive devices. And in that particular area, there are stringent guidelines, JSTD 033, very challenging to implement using manual systems. And so automation is key and requires a connection of MOM to physical devices, material in the real world, all wrapped up in a solution that automates it and makes it efficient. So a lot of different challenges facing electronics manufacturers, but the one we're going to focus on, the solution that is key to what we're going to talk about, is around how do we enable all of that? How do we provide that competitive advantage, focusing on the quality and the automation of the SMT lines? First of all, it's worth thinking about why we focus on this area in terms of solution and capabilities, and that's because there's significant value and benefits in being able to automate and drive efficiency in electronics manufacturing. And these are some examples of where customers have benefited. This is an aggregate of different DELMIA customers, and some of the things that are addressed that we just spoke about in terms of challenges like increasing demand, the ability to significantly increase throughput and productivity is a significant enabler to that. In terms of quality, the ability to ramp up, the ability to do defect identification. And in terms of the pace of transformation, obviously companies are moving from make to stock to make to order, and looking at smaller batch and unique customization. And so the pace of that transformation, the ability to improve productivity significantly helps. And so there's an overall competitive advantage and ability to drive sustainable operations through reductions in cost and waste, and to have an impact on revenue and market coverage. So there is a significant amount of value to be achieved in driving automation and efficiency in this area of electronics manufacturing. So as you may have seen before, DELMIA covers a broad scope of different solutions for different aspects of operations. In terms of collaboration, all of the solutions we provide are designed to be collaborative. They're designed to bridge the gap between the virtual and the real worlds together and provide environments and applications that allow different stakeholders to collaborate on solutions. So in terms of the next layer down, in terms of model, so this is key to working in the virtual world, looking at process engineering and so on. We're going to look at some solutions later on regarding those areas. Not going to focus on that now. The optimized layer is where we bring the power of optimization engine technology to solve some of the toughest puzzles that industries have. So in high-tech, forecasting, sales and operations planning, detailed production planning and scheduling, and so on. The next layer down is where our solution fits for today in terms of the perform. So this is where we turn planning into execution across all aspects of operations. And based upon the challenges we're looking at, we're going to focus on manufacturing and production specifically, is where this capability, this innovation provides the most impact. And because the focus is on traceability and control of material at a very low level, at a machine level, The key is to have a connection to the outside world. So the IoT layer is a key part of this piece of the solution for electronics manufacturing. It's important to include the physical material elements into the production and manufacturing management. So this is where we're going to look at in terms of the innovation solution now. If we just spend a second to think about why that connectivity is so important and why it's something that has been a challenge for some companies to implement, I think we can summarize that in sort of three aspects. Why connectivity? Well, it's part of the philosophy of the virtual twin experience, which we provide as part of the 3D Experience platform and the DELMIA solutions. It's a key to bridging the gap between the virtual and real world. And it's more than just a connection, though. It's a closed loop synchronization of the virtual and real worlds. And so it helps us improve productivity by having confidence in knowing what's happening in real time. It allows us to get information and insight into predictive maintenance based upon machine performance, by improving quality, by analyzing patterns in equipment and material data. So it makes us smarter by tracking material and making better decisions. And this is key in high tech due to the sensitivity and nature of electronics manufacturing, especially in SMT lines. There are challenges of connecting to the physical manufacturing line, obviously, and some of those reasons are the fact there is a vast array of communication standards and semantics. There's many reasons why there isn't a single standard. There's pros and cons of each standard that has been developed. There are legacy devices and machines that can't keep up with changing standards. There's changes in network technology, and there's obviously vendors trying to dominate the space and make their standard their own. So some of the challenges are that there's been a proliferation of different protocols, semantics, and standards, which makes it very difficult to have an overall single solution. The DELMIA approach to that is obviously to have an open strategy, because we know that there's not going to be a single standard anytime soon, so that the best approach, we believe, is to have an open strategy. As we're not a vendor of hardware ourselves, as we don't have any allegiance to any specific hardware, sometimes those hardware vendors are trying to impose their own standards of connectivity. So we're agnostic to all devices and hardware, and we've adopted widespread industry standards like OPC-US and MQTT. And we also work with partners to build out that capability to connect and synchronize with more machines. And for electronics manufacturing and SMT, we partnered with the best-in-class solution from Kojiscan, and we'll talk a little bit about that now. So the MOM solution for SMT manufacturing is a combination of what we believe, obviously, is the best-in-class manufacturing operations management solution, DELMIA Operations, with the best-in-class machines connection applications from Kojiscan. Kojiscan is a leader in track, trace, and control for over 20 years. They're an expert and standard in connectivity within the electronics manufacturing industry, and they have the tools necessary for success for transforming customers' business. And they provide the connectivity that companies need to compete in this ever-growing, changing, and deeply competitive industry, as we spoke about in terms of the challenges. So we invite you to learn more about Kojiscan in general separately, but we're going to cover now the specific solution that we bring to the table together for the electronics manufacturing industry. So here is a high-level view of the combined solution of DELMIA Operations and Kojiscan. Again, the objective is the ability to leverage all the capabilities that a manufacturing operations management system like Operations brings to the table across the entire production assembly operations, including SMT. And this will enable us to drive compliance with regulatory requirements, with standards, by providing a directed manufacturing solution to specification, including the process, materials, user training, all the aspects of that we need to comply with. It allows us to distribute, enforce, and monitor the best practices across the entire manufacturing portfolio and drive out errors in production that result in reduced work, reduced rework, scrap, and quality issues. And it's the capability to synchronize materials and enable lean operations, maximizing our return on assets while minimizing waste. So to realize the benefits of that in high-tech SMT manufacturing, we need that connection to the real world. We need to find out what exactly is happening in terms of the material, the machines, and the process. And so we use open standards for the traditional elements of manufacturing on the left-hand side, and then we leverage Koji-Scan for the connectivity to the SMT line specifically. And in the layer at the top, the machine integrator facilitates the management and monitoring of all the production equipment at both the facility and the organizational level, supporting this standardized manufacturing process, which is so important for us to gain the efficiency and reduce cost and waste. So we're going to focus not on the left-hand side. Aprizo has been connecting to devices for a decade in terms of the ability. I think the unique part of the solution is the Koji-Scan aspect that we bring to the table. And so we're going to focus on the SMT piece and talk about how it addresses the issues specific to electronics manufacturing and specifically to moisture sensor devices and the quality related to that. So what's challenging about maintaining the quality in surface mount technology and conforming to industry standards like JST 033 for MSDs? So moisture sensor devices are obviously commonly used in the industry for many different applications. They require special handling procedures that must conform to the industry standards to prevent them from absorbing too much moisture prior to reflow. So the foremost objective of the system is to avoid processing components that have exceeded their allowable limit through the reflow process during the first and second pass, while maintaining an efficient operation, providing real-time status of materials and advanced warnings of expiration for decision making. So if you were doing this manually, there's several shortcomings. With double-sided boards having moisture-sensitive devices on the first side, there's a complexity in tracking the life of the components, which even becomes more complex when looking at double-sided boards. Since the first reflow doesn't count as a bake, the clock of exposure time continues to run after the second reflow is accomplished. So the first issue that comes to mind is, how do we assign a remaining exposure time to a specific board? The components in a reel that's been loaded, for example, all have the same remaining exposure time because they're all same moisture sensitivity level when they're removed from their moisture barrier bag. A single label speaks for all the components on the reel, but once those components have been mounted to the first side of a dual reflow board, it becomes necessary to assign a remaining exposure time for that board. And the logical way to do it is to assign to the board the remaining exposure time of the component with the least value on the assembly line at the time the board was produced. So complex enough. Ideally, we should have a remaining exposure time assigned to each individual board to facilitate tracking. It's only possible if each board possesses its own unique identifier. And the task of recording those exposure times manually for each board is just massive, and it is not practical in a high volume environment. Even if all the boards or batches of boards are identified with their expiration date and time, it's still difficult to track and queue all the boards or batches manually between the first and second pass based on expiration priorities. So there's 4 key elements that are critical to success to solving this problem. The first is being able to track, being able to uniquely identify the material that we're working with. The second is to be able to track the material in real time. The third is to be able to manage the process to ensure quality across all required operations. And the fourth is to make it easy for the operators. We have to have a system and solution that automates it to the point where we reduce the complexity for the operators and makes it easy to manage. So we're going to look at each one of these 4 steps in a little bit of detail and talk about how they specifically provide capability and benefit to the process. So this is a basic layout of what we need to perform the material identification as part of the process. There's a number of control units in use and readers to facilitate the process. We have barcode readers at the start and end of the SMT line, and a local control unit in the center with an RF antenna and touchscreen display, which is the heart of the system. The barcode readers assign the remaining exposure time to each PCB entering the assembly line in the first pass. There's 2 readers at the start and at the end, one on the top side, one underneath, so that the label of the PCB can be read whether it's facing up or down in the first or second pass. We have an overall control box interface, enables the system to stop the line if an error condition occurs. And the local control unit is networked to a central server, and that provides access to a central database and consolidates the data from every line that we have in operation. So when the PCB enters the assembly line in the first pass, the barcode reader assigns the remaining exposure time to that unique PCB. Each time a reel or tray of sensitive components is added or removed from the machinery, the operator just needs to place the tag near the antenna, and that will log the equipment material being added. The system automatically retrieves relevant information from the tag in the database. This is done, and the operator then performs a simple load or unload transaction using the touchscreen. So the system automatically keeps track of all the components loaded on the assembly line along with their location, the machine and the feeder position, and the remaining exposure time. The second set of barcode readers at the exit of the line, we use those to confirm that each board went through the process successfully. This is an additional control step in case of a line breakdown or if the boards are manually removed from the line before the process is completed. So a number of different control elements and sensors so that we can track the assembly sequence and the PCBs moving through the process, and also the moisture sensitive devices that we're loading into the process as part of the assembly. So by adding these different control elements and readers to the process, we enable this important second step of being able to capture that data and information about the components and the PCBs in real time. And this is an example of some of the information and data that's transferred between those different layers. So from top down to the equipment, we're passing down information about the bill of materials, the routing, and the critical information on the remaining exposure time. In terms of bottom up from the equipment, we're being able to capture information about tracing the material, inspection results, machine information about events and alarms perhaps, and the critical information being communicated in real time. So the board status and routing control. So the key here is to enable all these elements to talk to each other in real time, to have a real-time status of what's happening so we can ensure quality control and track that throughout the process. So just as a quick aside, we spoke about the complexity and the challenges of connectivity based on the multiple different vendors, protocols, semantics. The DELMIA approach is to be open agnostic. Kojiscan has the same philosophy in terms of the ability to connect to a massive variety of different vendors and their machinery, in terms of machine types and connections. And so this is just a quick and partial list of the flexibility and capability that Kojiscan has to continue that same philosophy of being able to connect to almost any part of operations and machines that customers have in place. So we have our connectivity in place. We have the ability to identify our material and components that are going to be part of the assembly process. So now obviously the key part is to be able to control that and to monitor that process. And the objective here again is to guarantee that our final product and assembly, our PCBs, are free of reliability problems related to the specific moisture-induced defects on our sensitive components. So the main objective of the system is to make sure the product is built per the guidelines of JSTD 033, prevent assembling components that have exceeded their floor life, and prevent assembling boards in the second pass that already have expired components on them or that will have expired components on them by the time we're complete. And the challenge is to perform all of this while maintaining an efficient operation on the manufacturing floor. So in order to achieve this, the system uses the parameters that are configurable by the user, the first pass minimum required exposure time in hours and the last pass minimum required exposure time. And these two parameters, the first pass and the last pass remaining exposure time, define the minimum exposure time required by the system to let the production run during the first and second pass without interruption. So let's take a look at how that works in a step-by-step view. So let's take a look at the first step in the sequence that allows us to manage and control the process in sequence. So let's say a PCB enters the assembly line. So after the barcode reader reads the PCB serial number, it stops it on the conveyor before it enters the first machine, and it will stay there so that we can do some basic validation steps successfully. So the system will first verify if it has any first or second pass data for it existing. If not, it assumes it's a new serial number. The system then will verify that all the moisture sensitive component part numbers required for this particular pass are loaded in the respective pick and place machines. If they're not there, then the system provides a simple list to the operator of the component part numbers that are required to run the product but are not yet loaded. The system also provides a list of the component part numbers that are not required but currently are loaded, and alerts the operator to remove them so that we can take those parts, put them back into safe storage and remove their exposure to moisture. At that point, the operator will load the missing reels or trays of components, remove any unused reels and trays by scanning their respective tags against the RF antenna, and perform a simple load and unload transaction. So when this is done, the system then looks at the remaining exposure time. This is the key part. So we look at the status of the remaining exposure time of all the sensitive components loaded on the assembly line, and we select the one with the least remaining exposure time. And the system compares the value to the first passed remaining exposure time, and will assign the remaining exposure time to the board if the criteria is met, and will release it for production. In that way, we're prioritizing those operations and components that have the least amount of exposure time remaining to make sure that we don't run into quality issues or perform operations that are unnecessary and end up with wasted parts. And the system will perform the proper error management and alert the operator if that condition is not met or cannot be met. So once we've passed all the validation steps, we've assigned the remaining exposure time, we prioritize which board and how we're going to efficiently work on the boards that are available. Now we go through the first pass, and the system assigns an in-process first pass status to that board. After our board completes the first pass, the serial number is read by the barcode reader at the exit of the assembly line, and the status of that board is changed to completed first pass, and we capture some basic information about processing of the board, and we capture that and log it in our historical database, line name, date, time, remaining exposure time at exit, and so on. Now, if a first pass board goes through the assembly line for a second pass, the process control in the second pass is very similar to the first pass process, but on top of all the validations that we described previously, the system also verifies that the board successfully completed the first pass before letting it go on to the second pass processing. So during the second pass, the system also assigns an in-process second pass status to the board and updates it to completed second pass when we read the board again at the exit barcode reader. And again, we capture some basic information about processing the board and log it again, the line name, and so on. So by having this process, we ensure that all the components are available, ready. It automates the tracking and alerting to ensure that expired components are identified. It releases the most time-critical work orders first, and also that PCBs that are not going to meet target exposure times aren't worked on unnecessarily. So this is some of the key aspects that enable us to get that fine level control around the quality and the ability to work effectively and efficiently without having rework, scrap, and waste. Of course, there is one more important consideration that we have to factor in, and that is that there is always some human interaction. It's a very automated process, but not 100% automated. So in order for companies to adopt this sort of solution successfully, it has to be easy for operators to use. And so in multi-shift operations, obviously several operators are involved in the manufacturing process of any given batch of boards. You add to this the complexity of tracking moisture-sensitive devices during first and second pass, and considering all of that on top of all the other tasks the operator has to perform, it's obvious the system has to be really intuitive and easy to use to not add to the complexity of the operator tasks. So it is highly automated because of the RFID technology and the automated scanning. The operator actually has very little to do to perform a transaction, since most of the data acquisition is triggered automatically simply by presenting a tag to the antenna field by the local control unit, and so on. Most transactions are actually performed without any keyboard data entry at all. And the software is designed with built-in validation that maintains data integrity throughout the process. It also has a high level of guidance. So whenever information has to be provided to the operator about what to do next, or what to do if an error occurs requiring operator intervention, the appropriate message is clearly displayed simply and effectively in the system messages area. And then finally, it's all about management by exception. It's about making sure that the automated things happen seamlessly and we just focus on the alerts. So from the main panel in the solution, there's a watch list that provides access to real-time inventory, physical locations, remaining exposure times, and so on, the whole status of the materials in the assembly line in one place. And we can set warnings and alarms in the system. And so the watch list will display those and text messages whenever a condition is met, and triggers the appropriate action when necessary. So overall, it's an enhancement to the operator process and doesn't add to the complexity of their already busy job. So to summarize quickly and to conclude, so obviously the control of moisture sensitive components is a complex issue. It's got several implications in many critical aspects of the material flow and assembly process. Especially for double-sided boards with sensitive components on the first side or both, it becomes very difficult to ensure that critical product quality and adherence to guidelines that we need without the implementation of an automated control system. And so we need a system that's easy to use, that works in real time, connects to all the machinery and materials that we have as part of the assembly process. And some of those benefits, are key and evident in the ability to provide a joint partnership solution like this for manufacturing operations management and SMT control in terms of securing lead times, getting visibility to active components, maintaining a database of all that information so we have historical information to go and track and analyze, automating the component tracking activity, and then providing a proactive way of providing alarms to prevent the work on components that are expired or will expire, and make sure we increase the quality and efficiency of the overall system. So the implementation of a system like this with these key benefits can lead to a very straightforward financial justification because of the extreme amount of savings due to improved quality, productivity, and material costs. And we believe that Dassault Systèmes and DELMIA and the Kojiscan partnership bring the best of the manufacturing operations management control and process control and surface mount technology control to deliver value for customers. So it's all very well and good to have innovation in terms of solutions. It's no good if you can't deploy them effectively. And so that's a challenge that we are faced with now today in our unique global circumstances. And so the second part of the innovation we'll look at is just a simple case study on how it is possible to provide efficient and effective delivery for solutions, even despite significant disruption. We always speak about the importance of business continuity, about providing sustainable operations, about the ability to continue to adapt and transform, especially in the high-tech industry, and the ability to not stagnate and just stay in place while other companies sort of move ahead. And so the normal process of selecting projects for innovation and having them delivered typically by vendors like Dassault Systèmes and consulting companies is challenging because of the disruption. So, for example, we have issues around labor availability, both from a delivery side and from a customer side. We have issues of worker safety, so especially when it comes to social distancing and thinking about projects which sometimes are very much sort of hands-on, and you think of significantly large meetings with consultants, vendors, partners, all in the same room together. Some of those are just now, infeasible or, potentially have safety issues related to that. And then we have simple things like travel restrictions, or some, restrictions that companies have in terms of the ability to simply travel from one place to another and be available in person. And so there's all of these issues in addition to reduced budgets. I think there are some elements of delivery that can help in terms of cost when it comes to remote connecting with companies to deploy solutions. And so, these are all challenges, but I would argue, what's the risk of not moving forward or not maintaining operations or not continuing to innovate? And there are plenty of organizations, certainly that we work with in the high-tech industry, that are still charging ahead with projects and innovation. And so I think it's a mistake for companies to simply say, well, this sort of project or innovation we probably need to put on hold. I think, the advantage of the spirit of the industry is there's always ways to find solutions to challenges and to continue to innovate. And so I'd argue that it's a dangerous strategy to sort of simply put off transformation and innovation, and there are ways to get it done despite the significant obstacles we encounter today. So we're going to showcase one situation where the Dassault Systèmes Global Services Group was able to achieve a significant go live without compromising safety, without compromising the speed and pace of which they traditionally work, and I think in some cases actually found a few surprising benefits or silver linings to the cloud, which added to the project. So in this situation, this was a customer that creates electronic products and devices, about 14 to 15 production lines, over 200 potential users of the intended solution. The solution set itself is based around DELMIA Operations. There were also some partners involved. And the challenges were to control production and flow of material across the assembly process, the automation of the test machines, to have a quality and audit process and outgoing stations to track quality and quantity. There was consulting for best practices on production execution and quality control. And there was a need for need to include traceability and reporting for business users. So it covered production processes, quality, warehouse operations, maintenance work, dashboards and reporting, ERP and automation interfaces included as well. So a very sort of typical broad set of typical project parameters for a very dynamic customer across a significant number of manufacturing facilities. We are all obviously living the new normal, as it's called. How we work today is very different than we did just a year ago. And the same is true for the way that we have approached or had to approach delivery of solutions. And so the before picture was typically projects like this would involve a lot of on-site meetings, face-to-face meetings where different stakeholders would assemble for project kickoff to make sure we define the scope and what we keep track of what's happening. Significant amount of on-site presence, and of course the after is exactly the opposite, where there's a very limited amount of on-site presence. And there were sort of 4 areas that we found were significantly impacted by the new normal compared to how we would have approached this before. And so in the first case, where we would provide support to the shop floor, there would be an on-site lead consultant that would be available to provide that instantaneous support and be located next to the people that were actually receiving the solution and be users and operators of the solution. In the after picture, that obviously had to move to a significant amount of support via collaboration tools. And so that would be done by chat and call groups to make sure that the same support could be provided, but in a way that didn't always have someone on site and putting themselves perhaps at risk from not being from social distancing. The second area, again, typically managed by the on-site lead consultant, was to provide visibility to what's happening on the shop floor and to see how some of the solution and the transformation was actually being received, adopted and execution. And again, this was moved to visibility of a different way, a remote way, through shop floor images and videos of the process. But again, what we found was that in both cases, even though we took the person primarily out of the on-site facility, there was effective ways to collaborate using tools and videos and images to still achieve the same effect and the same support. In the before picture, the third area, production deployment primarily done on-site, and again the after picture, all of that production deployment was done with customer support in a remote manner. And then finally, the work time, since we were normally used to being on-site with customers, most of the work would get done during that sort of work time, the work day, because that's when people are available. Actually, in the remote sense, or in the remote after picture, it sort of became less critical to work, at exact same times. And in that case, since we have resources located around the globe, it's possible and perhaps more amenable to leverage people in different time zones. And that's sometimes very effective. When you're working in parallel, you have the opportunity to work during work zones. And then when there is work to be done that's more offline or not in parallel, but in series, you can outsource that to different regions of the world and have a sort of continuous workflow rather than sort of a start-stop approach based upon the work time. So these sort of methods and processes existed already, obviously. I mean, all of these are available. But I think what we found at Dassault Systèmes in the way that we were forced to use these is these actually became a way to provide some efficiency to the process and provide some benefit which we perhaps wouldn't otherwise have thought of or deployed based upon that. But we found that overall there was a way to manage each of the typical interactions that would have happened on site in a reasonably effective way, sometimes a more effective way by doing it in a remote fashion. So in terms of the summary and what we found in the results of the overall project was that it was quite feasible to complete the end-to-end implementation, starting from solution design to implementation, deployment, and post-go-live support, all primarily leveraging remote or distance capabilities and connection. There was some on-site presence to facilitate some interaction with the business users, but the vast majority of the process was done by resources that in most cases were sometimes not even in the same time zone, and leveraged their capability to continuously support throughout the project. The flexibility was still there to provide delivery in terms of changing business scenarios in a very tight schedule. So it was found that the delivery schedule was not needed to be compromised because of the remote nature, despite the fact that there was coordination needed with other vendors for a smooth implementation, including integrations and coordination between multiple partners. And so as an end result, the benefits the customer found was the ability to increase productivity, reduce scrap. They digitalized their entire shop floor operations across the different lines and plants that we supported. We supported high volume and mass production business models that they had, and we provided them support for planning and scheduling optimization in the future using production data. And the integration, as I said, was part of that. So many different parts to connect, but all quite capable of being supported by a remote delivery methodology. So just to draw a final conclusion from this part of the innovation delivery process, I think, based upon what we see high-tech customers doing in terms of continuing to move ahead, disruption doesn't mean stagnation. It is difficult in some cases to find the business continuity and sustainability methods to continue transforming, but it is happening and companies are finding ways to do it. The industry transformation will continue, and as I've said, in the high-tech industry more than others, this pace of transformation is continuing more rapidly than perhaps in other industries. And so the bottom line takeaway I think you should all have from this is don't wait to innovate. Don't put off a project because you think it's going to be hard or difficult. You will see that companies and vendors can quite easily find ways to innovate and to find ways to keep moving forward despite disruption. So that concludes our section on innovation from solutions and delivery. Now we'd like to have you hear from one of the industry leaders in high tech, the Panasonic Corporation. And today we're very pleased to have Mr. Alex Shimada from Panasonic joining us. And he's going to share their story of the Connective Factory Initiative.
皆さんこんにちは。パナソニックの島田です。私はプロセスオートメーション事業部でスマートファクトリーの取り組みに携わっております。本日はパナソニックのコネクティッドファクトリーの取り組みということでご紹介をさせていただきたいと思います。本日はよろしくお願いいたします。では早速説明に入らせていただきます。本日のアジェンダです。まずパナソニックのご紹介をさせていただきまして、当社のですね青田の方からニューノーマル時代のものづくりというインタビューを実施しておりますので、インタビューをお聞きいただいた後ですね、我々の実際のパナソニックのコネクティッドファクトリーの取り組みについてご説明をさせていただきます。さらにですね、デジタル化がもたらす COVID-19 対策ということで、さまざまですねデジタルソリューションがこういった COVID 等の対策にもなりうるというところをですねご説明をさせていただく予定にしております。ではまずパナソニックのご紹介です。パナソニックは家電・住宅向けなどの一般消費者向けビジネスとほぼ同規模のビジネス2ビジネス B2B 事業を行っています。コネクティッドソリューションズ社 CNS は B2B 事業向けに主に6つの業界に対してソリューションを提供しています。そのうちの一つ製造業向けのソリューションを提供しているのがプロセスオートメーション事業部という事業部でして、そこにですね私も所属をしております。パナソニックは国内外に工場を持っておりまして、デバイスから最終製品まで幅広く製造しております。グローバルの製造拠点数といたしましては327拠点と、国内海外ほぼ同数の拠点を持っております。 パナソニックはそれぞれの地でですね、グローバルでものづくりを実践し、工場経営の技術ノウハウを蓄積しております。コネクティッドソリューションズ社 CNS はですね、サプライチェーンの領域のそれぞれの業界に向き合い、現場課題経営課題に対するソリューションを提供しています。大きくは製造物流流通というサプライチェーンの領域をですねカバーしているということになります。我々 CNS 社は現場に寄り添い、現場にお役立ちすることを通じてお客様と社会の課題の解決にお役立ちするということを目標にしております。特にお客様、パートナー企業様とパナソニックでですね、コークリエーション競争して、お客様社会全体に貢献するということを目指しております。それでは、当社CNS 社の上席副社長でプロセスオートメーション事業部の事業部長ですあります青田の方のインタビューをお聞きください。
今年に入ってですね、大きく、人、また物、またですね、情報というものが大きく分断をされてしまったという、事態に、世界中のどの企業も、どの業態も、影響を受けたわけですね。で、特に私たちのものづくりを中心とした、製造業のですね、会社、また我々がですね、直面したことは、まさに、ノウハウの分断、情報の分断、そういったことがですね、直面をしてですね、A 工場、B 工場、C 工場の生産進捗が見えなくなった。またですね、生産性、また課題、生産に直面している課題が見えなくなり、またそれを解決してたですね、スーパーエキスパートなものづくりのメンバーがグローバルに活動ができなくなってしまったということで、生産性が上がらない。で、サプライチェーンの問題もですね、必要なパーツや部品、ユニットがですね、リアルタイムに必要な分が入ってこないということに、なりました。これまで、いろんなですね、人間関係や情報の伝達、従来型の情報の伝達の仕方でですね、奇跡的につながっていた、ものづくりでおけるサプライチェーン、また生産性を維持、また向上していくスーパーエキスパートの皆さんの俗人的なノウハウ経験、そういったことによって支えられてた、日本のものづくりがですね、大きなリスク、また今後の課題に直面したということだと思います。そういうこともありまして、私たちパナソニックの中でもですね、私の分野は特にファクトリーを中心にしたビジネスを展開させていただいているわけですけれども、私たちの中でも同じことが起こっていまして、皆さんも直面されていると思うんですけども、そういう中でですね、やはり人物情報をですね、工場内、また工場間、グローバルにですね、つないでいこうというグローバルファクトリーセンター構想というのをですね、構想を立てておりまして、ダッソーさんと共にですね、検討を始めさせていただいているところであります。で、よくシステム的にですね、もう抜本的にやり直そうっていう時に、生産現場にもですね、お決まりのですね、やり方、標準化をやると、個別は許さないと いう形で、よくシステム側から現場に迫られてくるわけですけれども、そのアプローチは実は非常に困るんですね、現場からすると。自分たちの仕事のやり方、進め方までもですね、変えなきゃいけないっていう、一種アレルギーのようなですね、拒絶反応が起こってしまうということなんですけれども、各々の工程、作業、あるいはライン、検査の工程含めてですね、個別のものは個別でいいんだけれど、それをですね、しっかりとコントロールできる、情報がリアルタイムに同期できるようなデータベースを作らなきゃいけないというところが非常に大事だと思うんですね。で、そういうことをコアデータベースと呼ぶわけですけども、いろいろ今まで、人、あるいはまた工程作業に宿ってた暗黙のデータ、情報ですね。そういったものを、必要な要件、また諸言でですね、しっかりと制御できるデータ情報に仕上げるということが非常に大事だと思っています。そういう意味では、システムのですね、パッケージが上位から振り降りてきて、その通りにしなさいっていうやり方では現場は動かないんですね。で、現場の今のリアルタイムに本当に必要な情報をですね、しっかりとコアデータベースにつなぐために何をするのかというアプローチ。このアプローチができるのがですね、実は、ダソさんのですね、アプリストの中にございます。で、実はホワイトペーパーのようなですね、自分たちの特別と言われている、また、我々だけの独自のと言われているようなですね、作業工程の、内容をですね、しっかりコアデータベースに入れ込むために、一種ホワイトボードのようなですね、形で、自由に書けるわけですね。しかしプロトコルはしっかりとコアデータベースで連携してできるようにつながっていましてね。で、そういうものを組み合わせると、私たちが特別だと思ってた作業内容の情報が、しっかりと生産計画だったり、生産進捗だったり、その変化に対するアロケーションのですね、再検討、また指示、実行っていうところにね、生きてくるわけですね。そういう意味ではそのプロセスビルダーと言われる、ホワイトペーパーのような、一種アプリ系のですね、特殊カスタマイズ性を認めてくださるようなですね、アプローチ。それを、ダッソーさんのアプリソンの中にあると。これはですね、私たちにとっても決め手になりました。こういうこれまでの日本のものづくりに代表されるようなですね、属人的、またですね、暗黙知、暗黙な情報、こういったものを吸い上げてですね、しっかりとデータベースでデータ化してですね、整理化して、しっかりコントロール、オペレーションをですね、仕組みでやっていくということができるようになってきました。これこそですね、日本のすり合わせと言われていたものが、データ連携をするということに変わりですね、決して製造、作業、工程の中に潜んでいる、我々が持っている強み、特徴、ケーパビリティというのがですね、しっかり生かされたものづくりができると、信じています。
はい、インタビューはいかがでしたでしょうか。ただいま青田が申し上げましたさまざまな取り組みにつきまして、デルミアのソリューションを使った、取り組みということでパナソニックのコネクティッドファクトリーの取り組みについてご紹介させていただきます。 プロセスオートメーション事業部が担当する回路形成事業、熱加工溶接プロセス事業はともに60年を超える歴史を持つ事業で、パナソニックのコア技術を駆使し、回路形成分野の電子部品実装をするシステムと熱加工分野の溶接システムについてはグローバルでトップクラスのシェアとなっています。現在ではそれらのシステムのオペレーションをデジタル化し管理することでスマートファクトリーを構築し、サプライチェーン全体のスマート化に取り組んでおります。本日はこの回路形成分野の主力商品である電子部品実装機の工場での取り組みをご紹介させていただきます。実装機工場のものづくりです。これは実装機は1万8,000点ほどの部品で構成されており、お客様のニーズによって仕様が異なり多品種で生産ロット数が小さいという特徴を持った生産形態になっております。これまで高度な自動化が進んでいる実装工程や溶接工程でのスマート化を実現してきましたが、我々の顧客価値向上のために手組みの多い手動工程を主としたデジタル化にチャレンジしております。これにより受注仕様に対応した組み立て、そして販売見通しに基づく生産というものを同期させてお客様にお役立ちを提供しようというふうに考えております。この実装機の基幹部品、基幹ユニットは全て内製しておりまして、高度な自動化が進んでいる部品加工、そして手組みが中心となるユニット組み立て、これらのハイブリッドという形でですね、組み合わせによって使用を実現していくというビルドブロックものづくりを実践しております。お客様のご要望にお応えする編集変量生産、これは各々の工程で確立しつつありますが、サプライチェーン全体を長官すると個別最適な縦割りの業務運用になっているのが実態です。いわゆる個人のスキルやノウハウに依存しており、アナログ的なデータを担当者間のメールや口頭のやり取りで対応しているため、情報がつながらず無駄ロスが顕在化しています。変化の激しいお客様要望、少子化による労働力不足に追従するためにもシステム活用でものづくりプロセス全体をコントロールし、面対応による辛くて早い組織体制の変革が重要課題と認識し、取り組みを推進しています。目指す姿はシームレスな業務プロセスの構築です。個別最適とはいえ、技能力をベースとした各従業員の知恵と努力で培ったノウハウや業務改善は貴重な財産であり、今後も継続して取り組んでいきたいと考えています。個人に依存した暗黙知にとどめるのではなく、可能な限りデジタルデータに置き換え、必要な情報を共通データベースに蓄積することで、欲しい情報が自由に活用でき、人から人への伝言ゲームが排除され、効率的な業務プロセスが構築できる、いわゆる面での課題解決が可能となり、変化の激しいお客様要望に追従できる効率的な編集変量生産体制に進化できると確信しております。目指すべき姿を実現すべくスマートファクトリーへの変革を推進しております。倉庫業務の WMS 導入による業務改革、ISP 管理や工程計画のシステム化、さらには設備の稼働状況の見える化による稼働率向上、組み立て工程の生産状況の見える化、データのデジタル化などを重点取り組みとして継続的に推進してまいります。それでは具体的な取り組み事例についてご紹介させていただきます。組み立て倉庫業務のデジタル化、自動化効率化の事例です。まず作業ナビによる間違いない仕組みということで、主にはですね、このページにありますのは紙を排除して電子帳票を活用するということになります。作業ナビによるオペレーターが間違いない仕組みや、工数進捗管理というところでタブレットへの登録、あるいはスマートロジスティック推進ということでピッキングリストもタブレットで表示ということを推進しております。 また人手による部材運搬も自動搬送システムに置き換え自動化を図っております。さらに取り組み事例の2といたしまして稼働監視システムを導入することによる機械加工の見える化に取り組んでおります。これまでは単に設備の状態を見えるあるいはそのデータを貯めてですね迅速に改善していくということをやっておりましたが、さらにですね停止ロスの極小化を目指して迅速に動かすということに取り組んでおります。現在のところですねこの迅速に改善するというところまでですね前年比で稼働率が 33% 向上しているという状況にあります。さらに迅速に動かすに取り組んでさらなる改善を図ってまいります。このコネクティッドのスコープですけども、工場内お客様上流工程をデジタルデータでつなぎ徹底活用するということを目的としております。工場内のコネクトによるサプライチェーンをコネクトする、あるいは検査工程をコネクトすることで工場内の品質管理を強化する、顧客とコネクトすることにより顧客の稼働状況を見える化する、あるいは設計工程をコネクトすることにより顧客での使用状況を設計情報にフィードバックするといったものに活用していきます。現在は日本のマザー工場にて取り組んでおりますが、各工場の特徴を生かしつつ製造情報をグローバルで集約し上位システムと連携させグローバル最適生産を実現すべく横展開を図っていきます。2022年度までにはですねグローバルに展開をしていきたいというように考えております。それでは最後にデジタル化がもたらす COVID-19 対策ということで紹介させていただきます。このコロナウイルスによる影響でデジタル化の波がさらに加速すると見ております。これにはリモートワークの需要であったり作業者が工場に来れないことによる作業者の不足といったものに対応するためにスマートファクトリー化の取り組みが加速するものだということであります。例えばこれは私どものお客様の事例ですけども、1階にこの実装機をですね数十台並べておりまして、これを2階の集中管制室でモニタリングをしたり、あるいはオペレーションをしたりということをしております。リモートでの操作が可能となっております。こういうことを通じてですね1階の作業者は極小化できまして、2階からの作業指示に基づいて1階が効率よく動くということがもう実現できるようになっております。あるいは非接触型のソリューションということでペーパーレスハンズフリー化、現場の情報の記録あるいは収集ということもですねペーパーレスでやることが可能、あるいは先ほどの1階2階の事例にありますようにカメラを活用してですね現場の見える化をしてさらに進化させることができます。作業者動線の把握あるいは分析最適化といったことにも活用が想定されます。こういったパナソニックの幅広いソリューションを活用し非接触環境下でデータの収集省力化自動化を実現できることと思っております。さらには自動収集されたデータに基づき生産をシミュレーションし人員の最小化あるいは動線を最適化するということによってオペレーターの密回避ということが可能になると考えております。これらのシミュレーターによる最適化によって最適なオペレーションを実現いたします。このように当社のですね製品単体ではなくシステムあるいは使い方といったものにものづくりのノウハウをですねソリューションとして提供しお客様に貢献してまいります。コンサルテーションからお困りごとや潜在課題の発掘をし経営成果に結びつくソリューションを提供させていただきたいと思っております。 本日は長いお時間お付き合いいただきまして誠にありがとうございました。これからもパナソニックのソリューションにご期待ください。ありがとうございました。
Well, thank you to Mr. Shimada for sharing his great presentation on some of the important work that's being done at Panasonic around their connected factory and some of the important strategy that's taking place at Panasonic. Now for the last part of our high-tech track, we're going to take a look at some more innovation in terms of industry solutions, this time around process engineering. Before we dive in, we're going to take a quick look at the overall breadth of solution scope that we offer in high-tech. We're going to then focus on process engineering and look in detail at the virtual build solution and then wrap up with a summary. We've spent a lot of time previously looking at some of the execution elements of manufacturing, some of the production elements, connecting to the real world. For this particular piece, we're going to stay firmly in the virtual world. This is all about simulation and how to get the most out of solutions like process engineering to really gain benefits in terms of optimizing production, time to market, without any risk involved or excess cost or wastage. So this particular part is about the modeling aspect of the DELMIA operational solutions and specifically process engineering. As we look at the process engineering solution portfolio, we're going to take a look at some of the challenges briefly, and then we're going to look at the virtual build solutions relevant specifically to this aspect of the DELMIA solution scope, specifically how it addresses these three specific questions of what are we manufacturing, and in that particular aspect we're going to look at the conversion of our engineering bill of materials to a manufacturing bill of materials. We're going to ask the question, how are we going to manufacture it in terms of the process plan? And then we're going to look at where we're going to manufacture it in terms of the resources, workstations, and so on, and look at the true virtual build simulation, and then we'll wrap up. When we look at challenges in process engineering, sometimes it's captured very well by this one statement called the digital divide. The digital divide between engineering groups and manufacturing groups. Each of these groups are critical to the success of our organization in terms of manufacturing new and innovative products. But typically they are very separate in nature. For a start, they use different tools. So the engineering group will be using CAD, PDM tools, and so on. Manufacturing are using manufacturing operations management tools like Aprizo and MES tools. And not only are these tools different, but they're designed for different intents. They have different context of information. There's typically no flow of information between engineering and manufacturing. And more importantly, there's no feedback loops automatically built in. And so it doesn't help us if we can't manufacture what we design and bring to market products in a cost-effective way. And so this digital divide is a significant issue and challenge between the holistic view of bringing products to market in the most effective way. And this digital divide has real consequences in the real world, especially in the high-tech industry where innovation and product variants are exploding. The need to bring products to market very quickly is paramount. And so if there is a break between engineering and manufacturing in terms of flow of information and collaboration, that results in lost time to market, could result in delayed orders, could be quality issues of the product because we're manufacturing things in ways that we didn't understand in terms of how we would be able to manufacture them when we were designing them. Potentially safety for workers as well if we're looking at how workers interact with the process plan, and of course cost due to rework, waste, excess materials, and so on. So it's very important to address the digital divide, and what we're going to talk about now is the solution that we have that enables that digital divide to be bridged. So here is a classic process engineering scenario. We're an electronics manufacturer of high-tech connected products, in this case connected speakers. They're fairly complex. It's a new product launch for our organization, highly competitive market, margins are very slim. And so what we really need to know in terms of this particular scenario is we need to know what we're going to manufacture, we need to know how we're going to manufacture it, and we need to know where or what resources we're going to need to manufacture it as well. So let's start off with the what. This is the classic conversion of an engineering bill of materials to a manufacturing bill of materials, which asks the basic question, can we manufacture what we have designed? Not only that, can we do it efficiently? And can we do it in a way that eliminates costly and time-consuming prototypes that we'd either have to manually make? So we want to do all this in the virtual world, reap the benefits of being able to do things quickly, without risk or cost, and really start to understand how we've taken all this great design and ideation that the engineering group has come up with and turn it into something that we can start to leverage for manufacturing. So first thing we're going to do is search for our engineering definition, our engineering bill of materials. That's our starting point, and we can use this interface to graphically take a quick look at all of the aspects of the E-bomb. We can see all the components that go into making up our particular product, but this again is a simple definition of the component parts, but it doesn't tell us, how to manufacture it. So we can move from here to move seamlessly into the creation and definition of the manufacturing bill of materials. We can start to lay out a basic structure of what the build-up is going to look like. We can do that graphically, and we can drag and drop parts into the structure and start to see the dependencies and the relationships from the starting point all the way back to the lowest part of the engineering bill of materials. So in this particular case, our product has a number of different variants. So in the frame here, we can drag and drop different variants of the frame into the process. So we have a standard plus and a pro version of our products. And by the way, we can filter all the way through the process on those different variants just to see the relationship or the M-bomb or E-bomb related to those specific product variants. So you'll notice how some of the ghost images from the E-bomb help us visualize the assembly parts. We can use the tree or the tiles to graphically sort of visualize what it looks like. And when we've completed the M-bomb, we can also see a simulation of the build-up, either by clicking the steps in the tree or using the visual view. And now that the M-bomb is complete, we can now start to leverage this model to start building out the process plan in the next step. So our next step here in terms of the process plan is about the how. How are we going to manufacture this particular product? How do we validate our process plan and our manufacturing steps that we're going to take in order to make sure that we can identify issues without risk, we can validate the process before release, and we can reduce product launch times by virtually simulating the process plan and seeing what issues might be brought up before we even set foot in the facility floor. So again, we're going to seamlessly move from manufacturing bill of materials to now our process plan and start defining the process. And in this particular example, we're looking at the final steps of assembly, bringing the front and back to enclose the internal framework of our product. If we drill down into the frame of our product, you can see that the process steps which are required at this next level down, and we can look step by step at what parts are added at each stage of the process, the timing, the associated components that are part of that process step. And so this is really where we start to understand the build-up based upon the sequence of steps, and it really starts to represent the beginning of the virtual build. So the virtual build represents our final question, which is where? Where will we manufacture this product and with what resources? And this allows us to do a complete build-up of every step that we've put in place so far, the manufacturing bill of materials, the process plan, and have a true virtual build which allows us to see what resources we need, how to improve resource utilization, identify potential quality issues so that we can reduce work and scrap, and do all of these things that, again, we would have to do normally with a manual prototype at great cost and time, which would lengthen the time it takes to bring products to market. We're not only shortening that time, but we're also increasing the quality and validation of the process steps as we go. So we're going to continue to build context to our model. And at this particular stage, we're going to start adding our resources needed for each step. That would be workstations, tools, machines, whatever aspects we need to complete this process step. And these all come from predefined catalogs, or you can create your own unique resources if there's something specific in your manufacturing process that we don't have, but we have a pretty exhaustive set of capabilities. And we can start to build up now a virtual view of the build step using 3D or two-dimensional tools. And so we're going to combine the manufacturing bill of materials and the process plan with the resource structure and now start to pull it all together into a virtual build. So we have each of our stations identified and modeled, and now we can start to look at, we can simulate what the build would look like, and we can start to position the product in 3 dimensions at the workstation and bring in all the resources as well. And this can be specific to the different product variants. So remember, we have 3 different types of products here. We have the Standard, Plus, and the Pro. And so each one of the views and the steps through the virtual build created from the process plan can be unique to those specific variants. So we can start to simulate now what the build will look like according to the process plan and all the elements that are involved in each of those steps. And at any step, we can zoom in to see some of the details behind the process step. We can see, for example, any of the different elements of the process step, the resources required. And what we're going to do is we're going to zoom into one part of this and look at the placement of one of the speakers as part of our product. So we have 2 speakers that are part of the product build. They're installed using typical resources, screwdrivers, manual installation, and we can see all those elements. We can see down to the individual screws as well as any level of detail we'd like to see what level of dependency we want. And what we're trying to do here is we're trying to define how we'll install this speaker, and we can start to see any potential assembly problems. For example, as we look at the placement of this speaker, we can start to see that there's some wiring quite close to the speaker that may become a problem in terms of quality if there's a pinch point. So we can set tolerances in terms of clearance and what's acceptable, what's not acceptable. We can run simulations against how those components fit together in 3 dimensions to see how close the tolerance is or how close the relationship is between the speaker and the wire, and if we might pinch it in some way. And by running this simulation with different clearances, we can set different tolerances, we can start to see potential problems. And the idea here is that by running these simulations on this virtual model, we can start to see potential issues before we even develop a prototype, and we can see the list of potential issues, we can find worst case scenarios, and then based upon that, we can either adjust our work instructions, we can give additional guidance, or we can provide feedback to product development if we find that under any simulation, there's always going to be a specific issue. And one final step we're going to look at, since it's unlikely that we have a completely automated process, we're going to have some manual workers involved in our process plan and in the manufacturing operations. And so it helps the efficiency and quality of the manual interaction in our manufacturing process if we can develop work instructions based upon all the information that we have. So this is really asking the question, can we increase worker efficiency with all of the detail we've pulled together up to this point? So in developing the work instructions that will help our operators put this assembly together efficiently, we're going to take the visuals of our model that we've had throughout the process, and we're going to start to add annotations to it. So these annotations give the workers some context for what's needed to be done. It allows them to see any potential hazards or challenges or things to be aware of. We can add as much detail to this as we like, and we can repeat this for each step in the process plan, and we can do it for all of them, or we can do it just for the key elements. And so this will replace manual paper-based instructions that people would have used prior to this. The system helps automate much of the details of the elements. So, for example, here you can see that it's creating some of the visuals for us, which we can then go ahead and augment or highlight in any way that we want. We can adjust the colors or so, emphasize them in whatever way we want. We can add comments here to any part of this. We can also add pictures of tools if we want. We have a library of pictures. We have pictures of personal protective equipment or any other aspect that we'd like to bring in to show, again, context of other parts of the assembly that they may need to be aware of. and we can orient these and modify them as well, as much as we would like. We can also add any highlights or warnings that we'd like to make sure the operator is aware of specific parts of the process that require extra attention, or perhaps cautionary areas where there might be some additional details they might want to be aware of. Then we can publish this manually or via HTML, or more optimally, we can publish it directly to the manufacturing operation management system like Apriza or the MES system, so they're displayed automatically for the workstation operator. Going back to the themes that we've spoken about throughout the presentations that we've had today, the process engineering solution allows us to answer those key questions of what, where, and how, bridges that digital divide between engineering and manufacturing to give us some of the key components and benefits that drive our agility and sustainability. From the agility point of view, being able to mitigate risk, reduce our time to market, and increase innovation by being able to explore more opportunities for new product variants and new ways to manufacture the endless ideas that design and engineering come up with in a risk-free virtual environment. And then from a sustainability perspective, the ability to eliminate cost and waste, to eliminate the need for prototypes, reduce rework and scrap by finding out what potential manufacturing issues we might have before we start manufacturing, and improving productivity and resource utilization throughout. So again, a really important part of the overall solution scope, and an important part of providing key benefits to high-tech organizations in the high-tech industry today.